Hi Algebra. Today we're going to be taking a look at Learning Target 2.4, which is I can solve absolute value equations. So absolute value means the distance from 0 on the number line. That's the definition of absolute value. And an example of that might be, let's say, absolute value of 2. So to find that, you can look at a number line. So here's a number line, and here's the 0. And there's the 2. And you can count its distance away from 0. And when you count on a number line, you should count the spaces, not the dashes. So we count 1, 2 spaces. So the absolute value is 2, which is probably not surprising. But when we take a look at this example, absolute value of -2, and we find that on a graph, -2 is right there. And when we count how far it is away from 0, 1, 2, we also get 2. So the absolute value will make a number positive. Whatever is inside of it, it will make positive because distances can't be negative. So this +2 becomes positive, and this -2 becomes +2. So it doesn't just switch the signs, it makes it negative. It makes negatives positive, and it keeps positives positive. So we are going to look at solving equations involving absolute value, and as we go along, we will fill in the steps that we need to. So kind of taking a look at some of these here, I'd like to just try solving some of these and see what happens. So we've got this absolute value of -5r equals 20. So what that means is -5r could equal 20. Just like up here, this right here was the same as this. So that's a possibility. -5r could be 20. But just like up here, the inside became positive, but originally it was negative. So that means that what's inside of here could be a different sign. So maybe this -5r is actually -20, and then once you take the square root of it, it becomes +20. So that's another possibility. So either it's 20, and when it's in here and then you take the absolute value of it, you get 20. That could happen. Or maybe it's -20, and when you put the -20 in here and take the absolute value of it, you get +20. So both of those are possibilities. So when we solve this, we now just have 2 little equations that we can solve. So solve each one separately. So for the first one, I get r equals -4. And for this one, I get r equals +4. So if I were to plug those back in, you can see that they work. If I plug in a -4 right here, -5 times -4 is +20. Take the absolute value, it stays +20, which is the answer. Trying this one, plugging in a 4, -5 times +4 is -20. Take the absolute value of it, you get +20, which is what this says. So both of these answers are correct. So it looks like what we need to do when we are solving for an absolute value, or we have absolute value in our equation, it looks like we're going to have to set up 2 smaller equations and solve those because there's 2 different possibilities for the answer. So let's try another one. Taking a look at this one, again, maybe this right here is 23, or maybe this is -23. Either way, once you take the absolute value of it, it becomes +23. So I'm going to go ahead and set up both of those equations. Now I can solve these just like normal, just solve them separately. They don't have to do with each other at all. Okay, so there's one of the answers. So at this point, you might think, oh, the other answer would be the negative version. It would be x equals -3, because that's what happened over here. We had a positive version and a negative version, but be careful, that's not always the case. You could get a completely different number for x. So when I solve this one, well, right here, we have a fraction. And that is going to be happening. There's nothing wrong with fraction answers. It's just that typically we avoid them. But it is very difficult to come up with questions where both answers are going to be whole numbers or integers. So there are often going to be fractional answers. So this is our answer right here, -22/8. We should reduce that though. We don't have to write it as a mixed number. In fact, in algebra, you often leave numbers improper and we do not write them as a mixed number. But what we should always do is reduce our fractions. So when we do that, we have this number, -22/8. Well, my answer is going to be negative because negative over a positive is a negative. So I don't have to worry about that. I know it's negative. I also can see that 2 goes into both of these numbers. 2 goes into 22 11 times. 2 goes into 8 4 times. This is my answer, and this is my answer. Okay, those are the two answers. I can plug these back in and I can check them. So if I plug in a 3 for this x, I get 24 minus 1 is 23. Absolute value of 23 is 23. Okay, that one's pretty easy to check. The fraction one, maybe you'll have some trouble, maybe not. You can plug in this number into this x and put this 8/1 and just multiply straight across. That's probably the easiest way to do this. I'm anticipating that I will get an integer when I do that because my answer should ultimately be an integer. So when I plug in -11/4, 8 times a negative, that's going to be a negative, so I know it's going to be negative. 8 times 11 is 88. 1 times 4 is 4, so I have 88/4. 88 divided by 4 is 22, and it's a -22. -22 minus 1 is -23. Absolute value is +23. So it does work, and you can check it even if it has fractions. Example number 3. So this one actually looks a little bit different here. I want to set up 2 separate equations, but I do that so that 1 equals the positive and 1 equals the negative, but here I have a 0. And there's no such thing as a positive or negative 0. 0 is in the middle. So for this one, I can't set up 2 separate equations because I can't write a positive version and a negative version. So the distance, if this is 0 away from 0, there's only one number that is 0 away from 0. So that means that I can just go ahead and set up one equation for this. I'm just looking for one answer because there is only one answer. There's only one place that's 0 away from 0, and that's the 0. So that's why it equals 0. So then we can go ahead and solve this. So taking a look at solving that, I get 3n equals -4. Divide by 3 on both sides. N equals, and yes, this is a fraction. Please don't put it in the calculator and get a decimal. Please don't write it as a mixed number. This is an improper fraction. We're going to leave it alone and reduce it if necessary. This cannot be reduced, so that is my answer. I want to take a minute and fill in some of the notes at the top. So based on the things that we've learned. So I know that when we're doing this, we should set up two separate equations. So I'm going to actually write that in step 2 because I know it's coming and I know that I need to write something else in for step 1. So step 2 is set up two separate equations and solve. Okay, so that's what we did here. We set up two equations, and then we solved those. Step 1 we'll fill in a moment. So far we've seen two different types of solutions. We've seen a type where there's two answers right here, two answers. So they could have two answers. Or they might just have one answer. So I'm not quite sure if that's all the possibilities, so we'll wait to fill that in. Absolute value equations have blank types of solutions. I know they have at least two, so I want to take a look at that and see if there's anything else that we can put in there. I'm going to put in a couple example problems here. So maybe we have absolute value of x equals 5. And so the two solutions of that, because this would be a two solution example, would be x equals 5 and x equals -5, because the inside here gets set to the positive version and to the negative version. So we've done that. Then we've also had the case where some absolute value equals 0. And in that case, there's just one answer. You just take whatever's inside the equation here, in this case x, but it could be anything. It could be 3n plus 4, for example, and you set it equal to 0. If there's anything to solve, then you would solve it. And then looks like there's this third type here, which I don't think we've seen yet, so we'll hold off on doing that until we've seen it. Let's look at example 4. This says absolute value of 2p minus 1 equals -3. And at first glance, this probably doesn't look like that big of a deal. But what this is saying is whatever 2p minus 1 is, whatever that is, and we don't know what it is because we don't know what p is at this point, but whatever it is, you're going to take the absolute value of it, and the answer is going to be -3, which hopefully is setting off some alarm bells. Absolute value's job is to take something and make it positive. So how could you apply an absolute value and then have a negative answer? It doesn't make sense. You can't do it. You would not be setting up two separate equations for a positive and negative version because the question itself makes no sense. You can't take an absolute value and get a negative answer because no matter what this is, you're going to make it positive with the absolute value, and positive numbers can't equal negative numbers. So example 4 is no solution. So that is what goes in your notes up here. Absolute value of x equals some negative number, maybe -4. That's going to be no solution. So absolute value equations have three types of solutions, and those types are two solutions, one solution, no solution. Take a look at the bottom of the page here. There are 4 you try problems. Please do those now. Pause the video, and when you get back, I will have the answers here. All right, welcome back to the video. We have the first one here, which does have 2 answers. You should have set up 2 equations to solve, one with a positive 76, one with a negative 76. Solve them each separately. The good news is that when you're solving these, the steps are the same for each one, but you will get different answers. So notice when I solved this, my first step was to add 4, and my second step was to divide by 10. It will be the same for the other equation. You will be getting different results though, but you're still adding 4 first and dividing by 10 second. So at least you don't have to do the work of figuring out which steps to do next. Once you do it for this equation, you're doing the same steps for the other equation. We do get a fraction here. When you divide by 10, you get -72 over 10. You could type that into a calculator and get -7.2, but we prefer improper fractions. So this is the correct answer. Reducing it will get you a better answer. So 2 goes into both of these numbers. 2 goes into 72 36 times, 2 goes into 10 5 times. So that's how you reduce that fraction. Taking a look at the other one here, it starts off with a fraction, but when you get rid of a fraction, you actually end up with a whole number. So our answer won't have a fraction. Setting up both equations, one where it equals positive 3, one where it equals negative 3, solve them both. For this one, we needed to subtract the 4 first and then multiply by 8 second. And that's the step in both problems. So I get negative 8 and negative 56. For the last one here, I started to work this out. I started to write my equations out, and then I realized, wait a minute, it's equaling a negative number, so that doesn't make sense. So this is no solution. We can't have an absolute value that equals a negative number. And then for this one, we only need to set up one equation because there's only one number that is 0 away from 0. So we get negative 7x equals 0, and then solve it to get 0 as the answer.